Our objective for today, I can add and subtract polynomials. Three together. 1, 2, 3. I can add and subtract polynomials. So yesterday I did an intro for adding and subtracting polynomials. We did the whole idea with the pet shop. Remember that? And then we also applied that to using the algebra tiles. I was using kind of like geometry and the area model, and I'll explain that later. So polynomials, we already took notes for that, so we don't need the Fourier model. We know that polynomials are monomials, or sum and difference of monomials, yes? And then I gave you guys these examples for the polynomials, these for non-examples, and we said that they are expressions only with various terms, okay? From there, I gave you guys some steps, and you wrote down steps. Oh, sorry. We wrote down some steps, first to distribute, which is to multiply, identify like terms for step 2, use commutative and associative properties to combine like terms, which is add and subtract, and at the end, simplify. Those are my 4 steps. We don't need those today. Once again, we already have the notes. From there, I went into explaining the pet shop. Remember that we were going to sell dogs, cats, dolphins, and we were going to have handling money at the store, right? So from there, I went ahead and got tiles out. We did the area model with tiles, combining like terms with the big X squares, the little squares, and all that, right? All right, but then I wanted to clarify some terms, so I want you to take notes on these terms, please. I want you to write on your paper, instead of writing the box at the top, I want you to write constant, constant. So in blue, I have constant, and it says in parentheses, a real number. Okay? Everybody with me? So a constant will be a real number. Now above it, I'm going to give you an example of what a real number is. How about 23? Yes, Michael Jordan. That's a real number. That's a constant. What if I said negative 23? Yep, that's a constant. Any real number. What if I said 2.3? That's a real number. All those are real numbers. That's why those are called constants. What do you notice from those examples that I gave you that do not have a variable? They do not have a variable. That's why I wrote it with a capital letter. Once again, constants do not have a variable. They cannot be also not a variable or not a coefficient. Now check this out. Some of you still are a little confused with coefficients. Here it goes. If I was to give you, pay attention, look up, the expression 3x, and I said identify the coefficient, look up please, the coefficient of this expression is 3. It's 3. 3 is a coefficient. Why? Because it's the only number multiplying the variable. Let me show you another example. If I gave you the example of 4x squared, look up to the screen, please. And I asked you to identify the coefficient. The coefficient on this one, it's not the 2, it's the 4. 4, the number multiplying the variable. That's a coefficient. Let me show you another example. What if I gave you the expression y? Check this out. And I asked you to identify the coefficient. The coefficient for this one is the number multiplying the variable. What is that invisible number? 1. That's the coefficient. Are we there so far? Yeah. Is it clear in the vocabulary now? Okay. So now that we have a constant we said it's a number without a variable. A coefficient is the number multiplying the variable. Okay. So look at this polynomial. Look at it. Tell you never which are the constants in there. Constants.
8, 4, 5, 6.
Okay. So check this out. So I heard 35, yes? And I heard 12, but from now on, look up please, whenever you have a subtraction like this, I want you to include it with that number so it can become a negative. So the constants are 35 and negative 12. Does everybody see that?
Yeah.
So once again, from now on, whenever you see a negative or a subtraction, you're going to include that with that number on the right of it, and that's going to become a negative number. Are we there so far? Can you identify another term that has a negative? Do you guys see it? This one, right? So from now on, instead of doing add the opposite of the second number to the first, instead of doing that, you're going to circle this whole thing. From now on, it became a what? Negative 5x squared. Does everyone understand that? Okay, hold on. So, questions, comments on that? We're good? All right. So those are my constants. Now write this down, please. A variable or variables of the same kind. Write that in red, because I want you guys to remember it. A variable or variables of the same kind. So once again, they need to be the same kind of variable, yes? A variable or variables of the same kind, check this out. This is the most important part. Yes, they have to be the same variable. Focus, please. Copy that. They have to be the same variable, but also, this is important, look up, they need to have the exact same exponents in order for it to be a like term. Does everybody understand that? In order for this term to be like another one, they need to have the same variables with the exact same exponents. Copy that, I'll give you some time. So, exact same variables with the exact same exponents. Are we there? Alright, so check this out. Pens down, eyes up here. If I was to give you the same polynomial, pay attention please. Look up. Here's a polynomial. And if I was to start from left to right, look up please, and I'm going to box this one in red. Which other term has the exact same variable with the exact same exponent? Do you guys see it? This one. So I would box this one because this one is like that one. That's what we call like terms. So now, I go to the next variable. I'm going to circle this one, including that sign in front of it. What other term has a variable exactly like that one with the exact same exponent? And everybody says 6. Why? Because the same variable, same exact exponent. Are we there? So check this out. So, these are the same, and these are the same. Now, let me take a little sidestep, because this is what I started seeing from some of you making some mistakes. Here it goes. Look up, please. In the past week or so, pay attention, please, we were looking at multiplication and division of exponential expressions. Is that correct? And we said whenever we have two expressions of the same base, such as x to the 9th and x to the 14th, what happens to the exponents? You add them, right? So this becomes x to the 23. All right? What a coincidence. All right. So check this out. So we understand for multiplication we add the exponents, yes? And then from there I said whenever we have division, x to the 42nd over x to the 19th. What happens to the exponents? Subtract. 42 minus 19, what does that give us? X to the 23. Everybody with me so far? But notice here that, focus please, notice here that we did stuff with the exponents. Are we there?
Yes.
That was fine and everything for multiplication and division.
But not for adding and subtracting.
But for adding and subtracting, watch. For adding and subtracting, we do this. Watch. Look up, please. I take this, and I look at the other one. I write x squared. Who noticed that I didn't do anything to the exponents? I just rewrote the variable with the exponent. But look where I'm going to focus. Look up to the screen, please. I'm going to focus on the coefficient. 8 minus 5. What is that? 3. Okay, so I got that one done. Now I'm going to go to the x. Is there another x aside from these two? No. So I bring down the x, and I focus on the coefficient. What is positive 4 and positive 6? Positive 10. Are we there so far? And then at the end I look at my constants. 35 minus 12, that gives me positive 23 Michael Jordan. Are you with me? And that's combining like terms. We don't do anything to the exponents. Tell your neighbor what I just said.
You don't do anything to that song.
So copy that, please, and right next to it, let's make a note for ourselves. Put an asterisk, a heart, and you're gonna write, do not do anything to the exponents. And once again, 10Q, that only will work for what? Addition and subtraction of polynomials. Adding and subtracting polynomials. Okay? Once you copy that, I'm going to give you an example so you can write that down. Example Q. Copy this. We got 5y squared plus 2x squared minus 1 plus 2y squared. I'll give you some time so you can finish taking notes and then copying that example. And then we'll go ahead and do that one together. Okay? Okay, let's do this one together. Check this out. If you have your colored pens ready, let's use our colored pens. I'm going to start with red. I'm going to box 5y squared. Scan that polynomial. Is there another variable of the same kind with the exact same exponent? Yes. Here, so you box this one including that symbol in front of it. Since there are no other, I'm going to write y squared down here. And I'm going to focus on what? The coefficients. What is 5 plus 2? 7. You write that as a coefficient for that. Are we there so far?
Yes.
Okay, from there, circle the next variable. Is there another x squared anywhere? No, that means we just bring that one down, so that becomes plus 2x squared. Is there another constant other than negative 1? No, we bring that one down also, and we're done.
Bam!
Now think about this question. Everybody look up. Why can I not combine this one with this one? Talk it over with your neighbor, please. Because they don't have the exact same variable with the exact same exponent. Are we there? Okay. I'm going to give you another one. See if you can do this one by yourself. Here we go. Example super cube. Copy this down, please. 3x squared plus 4x minus 5x squared plus 2 plus x plus 6x squared. See if you can do that one by yourself. Go one step at a time. Go.
So at the end, on Friday, we're moving C?
Here goes the process. Once again, I usually start with red, so I'm going to box x squared, 3x squared. Is there another x squared?
Yeah, 4.
Yes, right here. Is there another one? Yes, right here, including that sign. Okay? And I'm going to write x squared. But I'm only going to focus on the what? Coefficients. I got 3 minus 5. What is 3 minus 5? Negative 2 plus 6. What is negative 2 plus 6? 4. So I'm done with that. Next, I'm going to circle 4x. Is there another x?
Yes.
Yes, right here. And I bring down the x. There it is. But I'm going to focus on the coefficients. This is 4, positive 4, and this is positive 4 plus 1, that's positive 5. Are we there so far? At the end, I write my constant, that's plus 2, and I'm done. And notice, who noticed that these are in standard form, from highest to lowest degree? Watch, this is the second degree, this is first, and this is 0 from highest to lowest. Everybody with me? Okay? So, with that said, copy these next ones down. See if you can do these by yourself. Example 1A and 1B. Copy those, please. Let me zoom in so you guys can see them. Example 1A and 1B.
Oh, that's too close.
Too close? Okay, my bad. Better? Add or subtract, and there's A and there's B.
Four.
Alright, here it goes. For A, I'm going to box my first term. That's P cubed. Is there another P cubed? Yes, I'm going to include that sign in front of it. I write P cubed. And I focus on the coefficients. What is 12 plus 8? 20. Okay? Is there another P squared? No, I just bring that down. Plus 11P squared. And I'm done. Why can I not combine those? Because they need to have the same variable with the exact same exponent. Are we there so far?
Yes.
Alright. For letter B. Here he goes. 5x squared. Is there another x squared? No, I bring that down. 5x squared. But check this out. Notice what I'm going to do now. Instead of going to the constant, I went to the variable. Is there another x?
No.
No, I write that here. Minus 3x. And then at the end, I'm going to focus on the constants. Negative 6 and positive 8. What is negative 6 plus 8? Positive 2. Now, why did I do that? Why did I start with a variable instead of the constant? Because I wanted them in what? Standard form, from highest to lowest degree. Does that make sense? Hands if you got that by yourself. Okay, let's do another one. Copy these. Examples 1, C, and D. I want to see what you can do with those. Go. So we got, for C, we got T squared plus 2SW, S squared, my bad, minus 4T squared minus S squared. For D, we have 10M squared N plus 4M squared N minus 8M squared N. If you can simplify those, please. Okay, here we go. I'm going to start right here. T squared. Do we have another T squared? Yes, and I'm going to include the negative sign in front of it. Since I don't have any more, I'm going to write T squared. But I'm going to focus on the coefficients. What coefficient goes with this one? 1 minus 4. What is 1 minus 4? Negative 3. That is correct. Are we there so far?
Yes.
Next, I'm going to circle the next one, S squared and another S squared. So I'm going to write S squared. Now I'm going to focus on the coefficients. Positive 2 minus, what number goes here? 1. So what is 2 minus 1? 1, and it's a positive. Hands if you got that. That is correct. Now, for the second term, you don't necessarily need to write the 1 there. Everybody with me? Okay. Let's go with this one. Let's see. M squared N. Here's another one. And here's another one. All three of them are the same kind. So I'm going to write M squared N. So what is 10 plus 4? Minus 8? 6. Hands if you got that by yourself. Okay? So, Any questions with these? We're good, right? Now check this out. In the homework, you're going to get something like this next one. Watch. Copy these, please. Example 2A. 2A shows parentheses 4m squared plus 5, close parentheses, plus, open parentheses, m squared minus m plus 6, close parentheses. And for B, I want you to skip maybe 2 lines for A. And then for B, we got parentheses 10xy plus x, close parentheses, plus, open parentheses, negative 3xy plus y, close parentheses. Copy that, and then I'm going to go over those. Okay? Go. Okay, pay attention to these. Notice that these are a little bit different from the ones that we've been working with, right? What do you notice on these? These have what? Parentheses. Everybody with me? So now check this out. Pay attention, please. It's going to go pretty quick, so don't miss this. Watch. This parentheses, the first one, does not have a number or a negative in front of it. Therefore, it's a positive number. Is that correct? Okay. This one, the second parentheses, does not have a number or a negative. Therefore, it's a what? It's a positive. Are we there so far? Look what I do when I identify that both of them are positives. Watch. What did I just do? Tell your neighbor. All you do is get rid of the parentheses, okay? And then watch. Let me show you why. Pay attention, please. Here goes the why. Why do I get rid of the parentheses? What would be an invisible number in front of this parentheses here? 1. What is 1 times m squared? M squared. What is 1 times negative m? Negative m. What is 1 times 6? 6. What is the invisible number here again? 1. What is 1 times 4m squared? 4m squared. And this is plus 5. Everybody with me? All I need to remember is drop the parentheses and bring down the plus sign. Are we there? Do we know what to do from there? Yeah, copy that, and I'm going to do the first term. I'm going to box the 4m squared. Is there another m squared? Yes, right here. So, m squared. What happens to the coefficients? 1 plus 4, what is that? 5. Next, I'm going to use, instead of going with a constant, I'm going to go with a variable. Negative m. Is there another m? No, so I bring that one down. Minus m. And at the end, my constants. 5 plus 6, that's 11. And I'm done. Everybody with me? Okay. So let's do this one together. Here it goes. Is there a negative in front of this parentheses? No, so I just write 10xy plus x. Is there a negative here? No, so I just write plus negative 3xy plus y. Whenever you end up, everybody look up with a plus and a minus like this, make sure you put this negative in parentheses. So, with that said, box this one, this is 10xy. Box this one, so let's see, x, y. What is 10 minus 3? 7. Is there another x?
No.
No. Bring that down. Is there another y? No. Bring that down. And we're done. Any questions with addition?
No.
Hold on. We got one last thing. Here we go. Check this out. Look at this one. Example 3b. Look up, please. 2 parentheses. But what do you notice now in between them? Minus. So check this out. Look what I'm going to do. Pay attention, please. In front of this parentheses, I know it's a plus, so therefore this is 7m to the 4th minus 2m squared. Are we there so far? However, look what I do to this next one. Pay attention, you're going to miss it. I'll wait. Alec? Here it goes. Look at this one. Look what I'm going to do. What did I just do?
Distribute
This negative makes all these their opposite sign. Who saw that? Who saw that? And do we know what to do from there? Yes. So for tonight, homework is found on pages 498 to 499, numbers 2 to 22 even. Have a good one, guys. Enjoy your homework. See you guys tomorrow.